Okay, good afternoon. We were doing last class curvilinear motion problems, and we were just stopped our class looking at a special curvilinear motion problem, what is called a projectile motion problem. When you say projectile motion problem in mechanics, rigid body mechanics, we look at that comes under the category of particle kinematics study. Of course, we have problems of kinetics involved that we will do later. Now, important assumption that is made in projectile motion is that you do not have any resistance for the motion of the particle undergoing projectile motion in a curvilinear path. That path is a parabolic path that we have seen in the last class. So because of this important assumption, what is happening? The two component motion of a projectile motion, one horizontal motion component, another one vertical motion component. Horizontal motion component energy remains same. That means velocity is constant in a horizontal component of the motion. Whereas vertical component of motion, the energy initially start reducing, it goes to the highest elevation, then it's become only potential energy of the system. Then again, the energy start converted into kinetic energy from potential energy. So this is what is happening. So that means the vertical velocity keeps reducing as it is going in the path from the start of firing. And it is going to be zero in vertical direction velocity. That's called the highest elevation point or point of reversal of vertical component of the projectile motion. And then again, it starts gaining its velocity. That means from the return motion, it is accelerated. So in the forward motion, upward motion, vertical component motion, it is motion under gravity where it is decelerating, and in the return motion it is accelerating. So this is what is that you should remember in the problem of projectile motion. What is very important here is it's simple case because acceleration is only constant here. So we have only three governing equation, two primary motion equation, one secondary motion equation. That's all. And we finished that in the last class with the understanding of one problem. We will continue with that. And after the class, Kunal Bhatia has asked a nice question that instead of throwing it at an angle, if I fire a gun vertically upward, what will happen? So it was a good question that when you fire it vertically up, it is a rectilinear translation in a vertical direction. So it is not a curvilinear motion, first of all. And if we are having the same assumption that the fired bullet does not encounter any resistance, so you are firing in a there is no wind blow or where there is no resistance acting, we make such an ideal condition. It is not so in reality. If we make such an ideal condition, then again it will decelerate first and achieve the highest elevation, and that point is called the point of reversal. And then again it will come back with an acceleration with the same magnitude, 9.81 meter per second squared. So it will reach back again the person with the same velocity with which it is fired. So the kinetic energy at the start and the end is same. So that is what is the special case of again that question has helped us to understand. So that problem, what is the question asked, is a rectilinear translation in a vertical direction. And what we have discussed was a projectile motion problem. So today we will continue with the projectile motion problem, and then we will look at the concept of relative motion, right? Yeah. So let me share for that this. Screen. I hope all of you are able to see the screen. And look at here, this is the problem where we were stopped last class. So here this bullet fire from this gun with 80 kilometer, 180 meter per second speed at an angle of 30 degrees to horizontal from the top of the hill, fired point A. And then it falls down on the valley, which is 150 meter down the hill top at point B. So you are asked to find out this X and the highest elevation. So in that process, we first understood there are four equations. Yeah.
Sir, actually, I was getting confused for this equation y equal to y naught plus vy naught t plus half at square. I didn't get it. How do you write it, sir?
Yeah, I'll explain. Yeah. So that's what. Okay. So you're asking about this equation, right? You're asking
So
about this equation.
yeah,
Yeah. So this equation is what now you have to understand what is this motion. This motion is the curvilinear motion, 2D motion. I am resolving the motion as horizontal component motion and vertical component motion. I think you do not
yes,
have a
sir.
doubt in it. So
No,
horizontal
sir.
component, if I look at, that is uniform motion. This you understand, right?
Yes, sir.
So this
Yes, sir.
equation you understand. It's simply x is equal to Vxt if x naught is 0. If x
Yes,
naught is
sir.
given position, then I should add that. So this is a simple constant velocity equation. So here we have only equation, one primary motion equation, x is equal to function of t. That's all. This is only equation.
Yes, sir.
That is what is we have written here. And then vertical component, if you look at, we have three more equations. So this is what I always write it. So let us take it now. This is y displacement and Vy is velocity and Ay is an acceleration. So now what is happening? This Ay is constant. That is 9.81 meter per
81.
second squared. So when this happens to be constant, I have y as function of t, Vy as function of t, and Vy as function of y. So these are the only three equations that I have. So what are my equations? It's only notations different. So we have the same equation in uniformly accelerated motion. So we have now y is equal to function of t. So that is only is this. You have studied s is equal to ut plus half a t square formula. The same formula. So it's vertical component. So here what is that is displacement y minus y naught equals ut is initial vertical velocity. So please mute.
Yeah, one sec, sorry, sir.
Yeah, correct. So if you look at here, so that is what is the first equation. So y minus y naught is what is my vertical displacement. That's equal to ut. U in place of u is what is initial velocity. That is vy naught. Vy naught is this. So you know vy naught is 180 sine 30. 180 sine 30. That is vy naught plus half a t squared. So a is what is acceleration, but now you know that this velocity vy next instant reduces. See, this arrow length and this arrow length is reduces. So it's zero in a highest elevation. So as the velocity in vertical direction till this highest elevation reduces, that is deceleration. This is always a good practice. I'll write this equation, but in this equation, what is a value? It's minus 9.81 or plus 9.81. That will be the doubt always students do have it. So that doubt is clarified from the reference point. So at the reference point, the initial velocity is known. What is that happens to the next instant the velocity? It is decreases. So I just simply put that a as minus 9.81, which is deceleration. So that's clear. So what is your doubt? Why this equation is written is
Why
the general
don't
form.
we take that 150 meter in that, sir? That was my doubt.
One?
Why
What is
the
it?
position y which you are writing, right? Y equal to y naught plus y equal to u plus 80. The y naught you are writing is the initial position. Yeah, right, sir.
Yeah, correct, correct.
And what position is y exactly, sir?
Zero.
Which position is it?
What is my reference? So in this case, I have taken 0, 0 point A. Supposing if I take here
That's
the
y naught
projectile
only, no?
point, this as reference, then my y naught will be 150 meters. If I choose, what is my reference that
Yes,
I
sir.
choose? Right? I can have a problem fixing a reference point in the path. That reference point, I choose point A. In this case, this y naught happens to be 0. So this happens to be 0. Because my reference point is A, so here y naught is 0. If I could have taken my reference instead of there, this point A, point C, and this if I call 0, 0, then what would have happened? Then my y naught will be this point. So that is 150 meter. I have to account here. That's why we have to carefully take that. So you have
Yes, sir. I
school
got it
days,
now.
you studied a formula s is equal to ut plus half a t square, where that
Half a
s is
square. Yes, sir.
displacement. The s is
Yes,
displacement.
I got
Y
it. Sir,
minus
I was
y naught.
actually getting confused because in the equation you had written x equal to x naught plus vxt. I thought why you haven't written acceleration over there. Now I see the acceleration over x-axis is 0 now. I get it, sir. Thank you, sir.
No, acceleration is there at y not 0, but you have an acceleration that is minus 9.81. The velocity is there here.
No, about x-axis there is no acceleration, right?
Huh?
About
What is it?
x-axis.
X-axis.
About the x-plane, there is, yeah, sir, there is no acceleration over that axis,
You
no?
can see it's very simple, man. Don't get confused. Vertical component motion is just you are looking from here. It is only you cannot see the path. I'm seeing in this direction. You are looking from here, suppose. Then what will happen? This entire path will appear. Something goes from point A, goes to the highest elevation C, and then comes back to this point B. It will be like a vertical motion. It's a very rectilinear motion. This component is a rectilinear motion. And we have these three equations.
Yes, sir.
So Vy, V is equal to U plus AT you are writing the same. Vy is equal to Vy naught plus AT. So if we do not have doubt in this, why do you have doubt here? I do not understand. And then these are the explicit function of time. So these two equations are called the primary motion equation. What is my third equation? Vy is function of x. Here it is distance. So it is Vy is function of y. So that is what is here this equation. Vy squared is equal to Vy naught squared minus 2a into y minus this plus. So this g I put, so it's minus sign here. So these are the three equations which you have already looked at in your rectilinear motion case, where the motion is considered in a horizontal direction. Now that component is in vertical direction. So these are well-known equations. You cannot have such confusion, right?
Yes, sir. Okay, sir.
Yeah. So now let us find out this x and y value here, right? Yc value here. So how do I do that? That's what we'll start with the today's class. So lecture number 37. Today's date is 21/10/2020. So in this problem, I know first equation is V x naught, correct? So V x naught. Actually, I require this. So let us just look at this. There was this. Just a minute. Why is this? I'm not able to see that. So here we have this equation. So x is equal to 180 cos 30t. That's first equation. So let's take the first equation. X is equal to x naught plus v x naught t. So this is 0 as my point A. Point A I consider 0, 0. So x is equal to Vx naught is 180 cos 30 t. Right. So in this I know now what is t is x by 180 cos 30. So I have to get this t value. So what is the time taken? Or it's the time of flight to reach at any time instant. Or if I put my point B is my final end, then I can find what is my time of flight. So how do I do that? Then I'll go to the primary equation, one of the primary equation, that is y is equal to y naught plus Vy naught t minus half g t square. So in this I am going to substitute now this t. So what will happen? This is going to become a path equation, y naught plus Vy naught into x by 180 cos 30 minus half into g into x by 180 cos 30 square. So now I can find in this what is my x, right? Because I know what is y. So y is what now yb. So I have to apply this for yb. So if this is yb, so yb is look at in this, yb is minus 150. because point A here, point B is here, so minus 150. So if I substitute here, minus 150, and I y naught is point A, this is so 0, plus Vy naught. Vy naught is 180 sine 30 x by 180 cos 30 minus half into 9.81 into x squared by 180 cos 30 x by this square. So I have here a quadratic equation in x. Solving this, I'd be able to have what is my x. So that value happens to be 3100 meters if I solve. Right? Then if I want what is my time of flight t, then I can find this simply 3100 by 180 cos 30, and that happens to be 19.91 seconds. So from point A to B it reaches in this much of time, and at that time what is my coordinate xb is given by 3100 meters. One can also do it like this. So instead of substituting for t, I can substitute for I can straight away use this equation find time also, because I know here instead of putting it to get x, I can substitute, take this equation straight away. In this I know what is my y naught 0, y is minus 150, so vy not known, this is not known, this is known. So I have a quadratic equation in t. So if I solve, I will get two values of t. So one would be negative value, another one will be a positive value. So you may assume that positive value is this, and then you can work out for xb substituting here. So I can get t from this formula, or I can get straight away x by substituting t in this, so that I have this. What is this formula now? This formula is my path equation. So y is equal to f of x. See here I have y is equal to f of x. All right. So I can have this path equation as well to straight away get this. That's one way of solving this for x. And for highest elevation, now since you have this t and you have this, now highest elevation, how can I get? I know what is the relationship for this highest elevation to get. I can use this formula. What is that formula? Secondary motion equation. So this fourth equation, I can look at it. In this, I know now at the highest elevation velocity is 0. So this is going to be 0. Vy naught we know, that is 180 sine 30, so 90 meter per second. And in this y is what we have to find out, and y naught is known. So I can easily use this fourth one and find what is my highest elevation. So let me use secondary motion equation, that is Vy square equals Vy naught square minus 2 into 9.81 into y minus y naught. So this is going to be 0 here. So Vy naught is 90 in this case square minus 2 into 9.81 into y. So this point y become yc. So I put yc minus 0. So I get from this yc as 90 square by 2 into 9.81. That's going to be equal to 413 meters. So I have now my highest elevation from point A. That's all. So if it is asked from point B, then I have to add 150 meter as well. From point B it is asked, then I have to add 150 is the distance between point A and B, vertical distance, that has to be added. So this is how you can solve the problem. Any doubt in this? Anybody? Okay. If no doubt, let us look at now the second question. So now your projectile is fired with an initial velocity of 244 meters per second. So I have here, I'm standing here, and then there is